Hello everyone, I am Dr. Joonghee Park. I am currently working as a researcher at the Cognitive Science Laboratory at Yonsei University. I mainly conduct research in education and studies connected with artificial intelligence. At Kyung University, I teach the development of educational service using artificial intelligence. Mm, It is an honor to participate in such a valuable presentation these times. As you can see, when I present the content, my English pronunciation is not very good. Uh, and I lack fluent speech. So I created a presentation material using artificial intelligence. Let's go.
Hello. Today's presentation is on generalized Sobel test with robust standard errors for statistical validation of serial mediation effects in educational and psychological research. When analyzing mediation effects, we aim to extend the famous Sobel test formula for verifying indirect effects or mediation effects and its verification method to propose a generalized Sobel test formula involving more coefficients multiplied together in a serial connection. Additionally, we have developed a Shiny app to make this calculation easier, and I plan to introduce it. The existing Sobel test method becomes computationally complex as the number of path coefficients increases and has the disadvantage of being sensitive to issues like heteroscedasticity and normality. As a solution, we have proposed a generalized Sobel test formula that addresses heteroscedasticity problems by applying the HC1 method, and we have developed a Shiny app to make it easy to apply. Through this app, researchers can verify the statistical significance of indirect effects even without the original data, greatly enhancing the reproducibility of research results. We expect that this method will make a significant contribution to helping researchers in the fields of education and psychology analyze mediation effects more simply and accurately. First, the Sobel test is used as follows for testing statistical significance in the process of estimating indirect effects among three variables: independent variable, mediator variable, and dependent variable. In the process where the independent variable connects to the mediator and the mediator connects to the dependent variable, the indirect effect is calculated by multiplying the respective path coefficients A and B. Then, by dividing by the standard error, we obtain the z-value. If the z-value is greater than 1.96, that is, if the p-value is less than 0.05, it is considered statistically significant. However, in this process, a formula is needed to calculate the standard error. The formula known by Barron and Kenny is the Arroyan exact test, which is Formula 2. There are also the Sobel test standard error, called the delta method, and Goodman's method known as the unbiased method. Calculators that compute the Sobel test primarily use Formula 1 and are provided on various websites. This time, through the question, how is the Sobel test calculated and on which sites is it calculated? Swing, I will introduce a few sites. First is danielsoper.com. The UI is simple, and when you enter the inputs, the results appear immediately at the bottom. Everyone, I'd like to introduce two more sites that are convenient to use. One is identical to the one I just mentioned, and the other allows for more detailed calculations. First, analyticscalculators.com uses the same method. I don't think additional explanation is necessary. Second, quantpsy.org's Sobel test calculates all three Sobel test formulas presented earlier and shows how much the values differ for each. However, as you may have noticed, all of them are calculating only cases with two path coefficients. There are sites that calculate about three coefficients, but they had errors and couldn't be used properly. So how should we solve this? That's exactly it. As you can see in Figure 2, the number of path coefficients has increased to 3. Specifically, we're going to look at the indirect effect in serially connected variables. If you look closely, there's one more path added. In that case, calculating the indirect effect is simple. You just multiply all three values together. But what about the standard error? When there were two, we multiplied the coefficients and standard errors with each other. So what should it look like when there are three? This is the method for calculating the standard error when there are three coefficients. This method was proposed by Taylor et al. Equation 5 is the Sobel delta method standard error, which can be somewhat inferred. Equation 6 is the Arroyan exact method standard error, which is also complex. Equation 7 is the method for the Goodman unbiased method standard error. The important point is this: by using these methods to obtain the standard error, we can verify the statistical significance of the mediation effect and obtain confidence intervals. This is a very important fact. However, this is not the issue. The problem is that if one more coefficient is added, it becomes extremely complicated. It's hard to imagine. Therefore, we use structural equation modeling tools like MPlus, Lavon in R, or AMOS, and calculate the mediation effect through bootstrapping. In this study, we present three research questions. 1. What are the Sobel, exact, and unbiased standard error formulas for indirect effects involving more than three coefficients? In other words, we aim to develop generalized standard error formulas through mathematical modeling for verifying mediation effects that include an increased number of coefficients. Additionally, our goal is to create an app that general users can easily use to apply these formulas, providing it to researchers for free. 2. What is the formula for the generalized standard error and how is heteroscedasticity described? The Sobel test has often been criticized by scholars like Klein for the issue that indirect effects do not form a normal distribution. Heteroscedasticity problems have also been identified. To address these issues, we sought to solve them using White's 1960 robust standard error correction method. 3. How does the generalized Sobel test compare with the bootstrap test? The reason for this comparison is that I have often encountered studies where mediation effects were not calculated. If the confidence intervals of the generalized Sobel test results do not significantly differ from those of the bootstrap results, it would be very useful because it allows for easy calculation. Therefore, we established research question number 3 accordingly. Now, here are the research results. It might be more complex than expected, but today I will explain only the inductive confirmation. In this study, we focused on generalizing the three Sobel test methods, delta, exact, unbiased, proposed by Sobel, 1982, Arroyan, 1947, and Goodman, 1960, through mathematical modeling. To achieve this generalization, we conducted a systematic literature review and developed mathematical models. For model validation, we utilized R and implemented the calculations using the JJStat package developed by the author. We proved the equations through mathematical induction and analyzed the models accordingly. First is the delta method of equation 9. When we input the value of n equals 2, representing the case with two coefficients, it matches what we are familiar with. For n equals 3, it becomes equation 11. By simply adding additional terms, we can continue to obtain calculated values. Since the other two generalizations follow the same method, we will explain them briefly. We also demonstrate that the Arroyan exact test is extended in the same way from n equals 2 up to n equals 4. Next is the Goodman unbiased test. This formula is somewhat complex. When Hrs n is greater than 3, you use the general formula as shown in equation 18. In the case where Hrs n has 2 errors, you need to remove the product of the standard errors at the end to perform the calculation. Please distinguish between equations 19 and 20 presented below. Next, this is the Shiny app created using this method. A Shiny app is a web application that operates statistical tools using R. Now here's the Shiny app. Click on the provided address to start it. First, you need to set a project title. This is for future use so you can access it again later. Then, input the path coefficients and standard errors and enter the paths. Each time you add them, the paths will appear on the right side. After that, click on Calculate Sobel Test, and the calculated results will appear. You'll see a summarized table and detailed explanations. At the bottom, the confidence intervals are visualized for you. Finally, you can save the paths and each result as an Excel file. If you save the first Save Current Paths as Excel, you can reload it anytime for further analysis. Next is the application of HC1 robust standard errors to complement the shortcomings of the Sobel test. As you know, I mentioned the issues in the Sobel test regarding the lack of normal distribution and heteroscedasticity. By applying this, the robust standard errors make it similar to actual bootstrapping. Contrary to concerns, when we applied it in practice, we were satisfied with the results. The formula is open parenthesis 23 close parenthesis, where n is the sample size and k is the number of predictor variables. For example, if the regression coefficients connected to M4 are M1, M2, and M3, then you would input k equals 3. This time, I have brought data from a study I conducted in 2024 on the online self-regulated learning and learning satisfaction model. In this model, I will compare only 3 indirect effects. I have differentiated them by coloring them with different colors. First, these are the results obtained through 5,000 bootstraps from the existing research model, along with the corresponding 99% confidence intervals. Then, for comparison, I calculated using the generalized Sobel test. Let's look at the results. The confidence intervals are not the same. Although they are not the same, I realized an important fact after checking through various models. The statistical significance was the same. In the bootstrap test, the fact that the confidence interval does not include 0 means that it was statistically significant. And in the generalized Sobel test, it also did not include 0, thus being statistically significant. I think the application of robust standard errors was quite meaningful. We are almost at the end. In the discussion, the first important implication of this study is that we generalize the Sobel test standard error through mathematical modeling. This means that there's no need for high-performance computing to verify mediation effects. Some might say that computers have become widespread in this era. However, think about this. Suppose you were reading someone else's paper. In that case, the research model only calculated direct effects and did not compute indirect effects. Then, we can immediately calculate it using just a calculator, and even obtain statistical significance by accessing the Shiny app on a smartphone. The second point is that we created a Shiny app to make this easy to use. Third, it's important that the bootstrap results and confidence intervals were somewhat similar, and the statistical significance was the same. This serves as evidence that this method is reliable. The conclusion is as follows. First, researchers can easily calculate the results of other studies' models in educational and psychological research using just a calculator. Second, while bootstrapping requires the original data and a high-performance PC, the generalized Sobel test can be simply calculated on a regular calculator or via a Shiny app on a mobile device. Third, by applying robust standard errors through the HC1 method, issues of normal distribution and heteroscedasticity are resolved, and the statistical significance matches that of the bootstrap results analyzed with the original data. Here are the references. Thank you for listening to the presentation. I am Joonghee Park.